Okay, so this is going to be my second quotient rule example. I did m of x divided by q of x. For the whole thing, I defined it as h of x. I'm just going to keep doing that. For m of x, I had 4x cubed plus 2x, and for q of x, I had pi x minus 2. First thing I did was define m of x and the derivative of m of x, and then I found q of x and the derivative of q of x. So for m of x, I used the power rule to actually find the answer for the derivative. I have a power of 3, so I multiply 3 by 4, and that gets me 12, and then I take 1 away from 3, that gets me the power of 2, so I have 12x to the power of 2. Then over here, x is actually the power of 1. You have 1 times 2, then x becomes to the power of 0, which takes away the x altogether. You have 12x plus 2 as the derivative, so that's my terms here for m. Then for q, I'm going to use the power rule again. X is to the power of 1. You have 1 times pi. So pi is just the answer. Because x is to the power of 0, there's no x attached to the 2. So it's gone. So the derivative is just pi. Now that I have all my terms, I'm just going to plug them into the quotient rule equation. I actually already showed that to you, the one I've been using in the first video, so I'm just going to use that. So first I have pi x minus 2 times 12x squared plus 2. So that is my q of x times my m prime of x. And then subtracted from that is going to be pi, which is my q prime of x, times 4x cubed plus 2x, which is my m of x. Then all of that is divided by my q of x squared. So actually, since this one is just like a lot of combining terms and distributing, the first thing I did was like distribute all of the parentheses. So first I'm distributing these two right here. So I have pi of x minus 2 times 12x squared plus 2. So pi x times 12x squared is 12 pi x cubed. They have that x in common. This x to the power of 1 can combine to x to the power of 3. The pi, I'm keeping in pi because it's more accurate, so it can just be 12 pi x cubed, and that's going to be okay for now. Then I'm going to distribute pi of x times 2, positive 2 right here, so we have pi 2x. I'll move it around later, but that's pretty much that. Then I have negative 2 times 12x squared, which is negative 24x squared. You can pretty much just multiply the 2 by here. Then we have negative 2 times positive 2, which is negative 4. So that's what I did here. I just distributed this first part. Then I'm going to distribute this part, so that way I can plug it all back in and solve out. So I have my pi times 4x cubed, which is 4 pi x cubed, and then pi times 2x, which is 2 pi x. Now that I have all of these terms right here and right here, I'm going to plug them back in where I had these ones. Now I have to take note of this negative sign, which I didn't when I was distributing. I just distributed positive pi. But when I plugged it back in, I did take into consideration that negative sign, and I did actually subtract and then subtract because I knew that there was a negative pi being multiplied. I didn't write that out here, but that's what I did. So I have my 12 pi x cubed plus 2 pi x minus 24x squared minus 4, and then here that negative sign that's being distributed to both terms. I have my negative 4 pi x cubed and my negative 2 pi x. So the best thing to do is combine like terms. We have this negative 2 pi x and this positive 2 pi x. They cancel out. This negative 4 can stay. Then this negative 4 pi x cubed can be taken away from this 12 pi x cubed. So you just take 4 away from 12 and you get just positive 8. So you'll see that in the next step. Then this one, this term can stay and this term can stay. And as simple as I can get it is 8 pi x cubed minus 24x squared minus 4 over pi x minus 2 squared is equal to h prime of x, which is the whole derivative equation. So this is my derivative of my example 2 using the quotient rule.